Hello students, let's start a new topic, straight line. The very first thing we will come to know about this chapter is about the slopes. Slopes are identified by m, or you can say m equals to tan theta. We have a concept for the slopes that suppose any line is there, and that line makes an angle of any angle with the positive direction of x-axis. If a line makes any angle theta with the positive direction of x-axis, that theta in the tangent form is called as slopes. Suppose this is a line A to B, and this makes an angle, this and this. But what we need to consider, the angle which is made with the positive direction of x-axis. This is the positive direction of x-axis, and this is the negative direction of x-axis. Negative direction, positive direction. The angle makes the positive direction of x-axis is considered as theta. So tan theta will be the slope. So tan theta will be the slope can be assumed with a different figure. Suppose any line is there and this line goes like this. Then how you will find the tan theta? You will just produce this line towards backward side, and this angle will be theta. And this theta means tan theta will give its slope. Similarly, you can have many more figures. Suppose any line is given like this. What you will do once again, you will just produce this line, and whatever the angle that will be, that angle in the form of tan theta will be considered as a slope. That will produce that line, and that line which will make any angle with the positive direction of x-axis, that will be called as a slope, and the theta in the form of tan theta will be called as slope. Now let us consider some more things. Suppose you have a particular case. Now this tan theta is called slope. Suppose you have a particular case. Suppose a line goes like this, then what's the angle will be there with the positive direction of x-axis? This line will be parallel to this line, then the angle will be 0. Theta equals to 0 for parallel lines. Theta equals to 0 means tan theta equals to tan 0 degree. And tan 0 degree means how much? That will be 0. And suppose you have a line like this. Any line goes parallel to x-axis, perpendicular to x-axis, means it makes an angle of 90 degree with x-axis. In this case, for perpendicular or 90 degree, theta barabar 90 degree implies tan theta equals to tan 90 degree, and tan 90 degree stands for infinite or not defined. You can say tan 90 degree stands for infinite or not defined, means this value will be not defined. So for in this case we have angle 90 degree. So this line has 90 degree angle with this positive direction of x-axis. So this angle will be 90, and that will be tan 90, that is not defined. The slope will be not defined, you can say. Slope will be not defined, you can say. And in this case, you can say slope is 0 when the lines will be parallel to x-axis. When the lines will be parallel to x-axis, you can say slope will be 0. So some more cases we can have. Or once again, we can have one more result from here. For the parallel lines, suppose this line is parallel to this one more line, So in both the cases, this line will have m1 slope, this line will have m2 slope. You can say m1 equals to m2 for parallel lines. m1 equals to m2 for parallel lines. m1 equals to m2 for parallel lines. And similarly, for perpendicular lines, this line is L2 and this line is L1, you can have m1 into m2 equals to minus 1. If this line has a slope of m1 and this line has a slope of m2, m1 into m2 equals to minus 1. If this line L1 will be perpendicular to L2, then the slope of their product of their slopes will be equals to minus 1. m1 into m2 equals to minus 1. Similarly, now you can have two results that for parallel lines you have the slope equal m1 equals to m2, and for perpendicular lines you have the slope perpendicular product of the slopes equals to minus 1, or m1 into m2 equals to minus 1. For parallel lines. For parallel lines, m1 equals to m2, means both the slope of both the lines will be equal to each other. For perpendicular lines. For perpendicular lines. Lines m1 into m2 equals to minus 1. For parallel lines m1 equals to m2, and for perpendicular lines m1 cross m2 equals to minus 1. Now you can have one more result. Suppose you have a line which has a coordinate of x1 comma y1 and one more coordinate x2 comma y2, and you need to find the slope of with the help of this coordinate. You have a line which has a one coordinate x1 y1 and another coordinate given to you x2 comma y2, and you need to find the slope of this line with the help of this coordinate. What you will do, you will just follow the formula m equals to y2 minus y1 upon x2 minus x1. m equals to y2 minus y1 upon x2 minus x1, where the coordinate y2, y1, x2, x1 all are given to you. So m equals to y2 minus y1 upon x2 minus x1. This will give you the slope of the line. The same slope will be taken out when you are taking theta with the positive direction of x-axis. In both the cases, you will get the same slope. M equals to y2 minus y1 upon x2 minus x1, or by taking the help of theta, you can find tan theta. That will also give the exact slope or the same slope you will get. Now next we will consider one more thing, that for parallel lines is much important to learn. Suppose it is given to you a point 3, 2 and another point is given you 5, or you can say 1, 2. So you need to find the slope of these lines. So how we will go? We will just find m equals to y2 minus y1, y2 minus y1 upon x2 minus x1 implies y2. We will take y1, x1 y1 and x2 y1, or x1 y1, x2 y2. So x1 y1 is this one and x2 y2 we are taking this one. So y2 2 minus y1. Y1 also we have taken 2, but you have to just know that if you are taking a point 2 over here, so here it cannot be 2. So this we have to change taking 1. So 2 minus 1 upon x2 minus x1. x2 minus x1 means if I have taken this as a y2, so this will be x2 x2 minus x1, x1 is 1. So on solving, what you will get, 2 minus 1 equals to 1 and 3 minus 1 equals to 2. 1 upon 2 will be the slope. 1 upon 2 will be your slope. What we have done, y2 minus y1 upon x2 minus x1, and here comes the value x2, y2, x1, y1. So y2 minus y1 upon x2 minus x1. One more question we can see. Suppose you have a line which is like this, and the coordinates are minus 3 comma minus 5, and here the coordinates are 3 comma 5. So what you will do, you will just suppose this is the x2 comma y2 and this is x1 comma y1. So x2 comma y2 means m equals to y2 minus y1 upon x2 minus x1. So what you will follow, y2 minus y1 means minus 5 minus y1 minus 5 upon x2 means minus 3 minus x1 minus 3. What you will get, minus 10 upon minus 9. Minus will cancel out. This will be 10 upon 9. So you will get the slope 10 upon 9. So today you understand about the topic of slope. So what was the slope? Slope is the any line, अगर कोई लाइन जो है पॉजिटिव एक्स एक्सिस के साथ जो भी एंगल बनाती है उसे अपन स्लोप बोलते हैं, उसे हम लोग स्लोप बोलते हैं। पॉजिटिव एक्सिस के साथ जो भी एंगल बनता है उसको स्लोप बोला जाता है। ठीक, अब ध्यान रखने वाली चीज़ यही है कि पॉजिटिव डायरेक्शन ऑफ एक्स एक्सिस की बात कर रहे हैं हम लोग, मतलब पॉजिटिव डायरेक्शन ऑफ एक्स एक्सिस वाले एंगल की बात कर रहे हैं। ठीक, अब दो लाइनें यदि आपस में पैरेलल होंगी तो दोनों का स्लोप आपस में बराबर होगा, m1 इक्वल टू m2। यदि दो लाइनें आपस में परपेंडिकुलर होंगी, 90 डिग्री के एंगल पे होंगी, तो दोनों के स्लोप का प्रोडक्ट जो है -1 के इक्वल होगा। दोनों के स्लोप का प्रोडक्ट -1 के इक्वल होगा। यदि लाइन के कोऑर्डिनेट दिए हों x1 y1 और x2 y2, तो स्लोप निकालने का फॉर्मूला है m इक्वल्स टू y2 माइनस y1 अपॉन x2 माइनस x1। ठीक, जैसे जैसे कोऑर्डिनेट दिए होंगे वैसे वैसे आप इसमें पुट कर देंगे और स्लोप निकल जाएगा। ठीक, नेक्स्ट टॉपिक हमारा पॉइंट स्लोप फॉर्म आता है और लाइन की इक्वेशंस आती हैं, उसको अपन नेक्स्ट लेक्चर में देखेंगे। टिल दैट, थैंक यू।